Scientists are constantly working to uncover evidence of intelligent life beyond our planet. But what would happen if we actually made contact with extraterrestrials? How would we interpret their messages? And what implications would such a discovery have for our society? In this video, we'll explore the various strategies scientists use to search for intelligence among the stars, the increasing role of artificial intelligence in these efforts, the types of signals we might encounter, and the potential outcomes of finally detecting alien life. Our search for intelligent life has been underway for decades. Scientists have employed numerous techniques, from scanning the cosmos for radio signals to examining exoplanets for signs of habitability. We've listened intently to the radio whispers from distant stars, yet so far we've found nothing, no definitive evidence of alien civilizations. Does this mean we simply haven't searched thoroughly enough, or that such civilizations are rare? If we consider Earth, life began at least 3.8 billion years ago, possibly even 4 billion years ago, shortly after the planet cooled and oceans formed. It then took about 4 billion years, roughly a third of the universe's age, for life on Earth to evolve from its simplest forms into a civilization capable of communication. If this timeline is typical, then the conditions needed for similar developments elsewhere might be exceedingly rare. Stars and planets must remain stable for billions of years, allowing life to evolve from single-celled organisms into complex multicellular life that can eventually create oxygen-rich atmospheres, cultivate plants, and build civilizations. Recently, researchers have developed an AI system that has detected over 20,000 signals of interest, 8 of which show distinct signs known as technosignatures. This exciting breakthrough has reignited our quest, as AI's capacity to analyze massive datasets rapidly could dramatically improve our odds of identifying extraterrestrial life. With AI, we can spot subtle patterns and signals that might otherwise go unnoticed. Statistically, the universe's sheer size favors the existence of alien life. There are an estimated 1022 stars in the observable universe, and we now know that planetary systems are common. In our own Milky Way, nearly every star examined seems to host some form of planetary system. With so many worlds out there, it's nearly inconceivable that life doesn't exist elsewhere, or even intelligent civilizations, somewhere among the stars. But what might these civilizations look like? Without direct evidence, we can only speculate based on what we know of life on Earth. Earth's life is carbon-based and depends on water, so similar conditions on alien worlds might yield life reminiscent of our own. On the other hand, alien life could be radically different, relying on alternative elements or solvents, evolving in ways we cannot yet imagine. They might be microscopic or enormous, simple or exceedingly complex, and their technologies could be so advanced that we struggle to comprehend them. Before we conclude, let's revisit one of the most intriguing signals in the history of SETI, the famous WOW signal detected in 1977. Astronomer Jerry Eman stumbled upon a powerful radio burst, unlike anything he had seen before. Its origin remains a mystery. It could have been interference, a bizarre astrophysical event, maybe even a black hole devouring a star, or it could have been a genuine extraterrestrial signal. Eman himself believed it came from beyond Earth, and to this day, the WOW signal stands as a tantalizing enigma. If we do detect an alien signal, what would it be like? The form it takes depends on the sending civilization's technology and methods of communication. Radio waves are one plausible form of technosignature, but interpreting any message would be challenging. We can look to our attempts at understanding dolphin communication as a cautionary tale. Despite extensive research, we still struggle to fully decipher their language. Decoding an alien language would be even more daunting, given differences in biology, culture, and technology. Interestingly, other Earth species have found ways to communicate across species boundaries, adopting shared signals that both groups understand. Dolphins, whales, and other animals sometimes develop a sort of mutual language to coordinate. But dolphins, as intelligent as they are, cannot build spacecraft or radio telescopes to communicate with distant worlds. If alien civilizations are primarily aquatic, they might face similar technological barriers, preventing them from exploring space as we do. Determining how close intelligent life might be is difficult. Even if a civilization were relatively close on a cosmic scale, they could still be many light years away. This makes two-way communication a slow and patience-demanding process. For example, our nearest star system, Alpha Centauri, is about 4 light years away. Sending a message and waiting for a reply would take 8 years, a snail's pace for any meaningful conversation. As we inch closer to making contact, we must consider the potential consequences. The discovery of an alien civilization could reshape our understanding of our place in the universe, challenge our religious and cultural beliefs, and stimulate new technological advancements. The ethical implications are equally profound. Should we share our technology? Might we disrupt their society or risk exposure to new pathogens? Addressing these questions will require global cooperation, careful thought, and guiding principles that respect the interests of both humans and extraterrestrials. As the search continues, our perspective on the universe and on ourselves will surely evolve. AI will increasingly aid us by analyzing data and detecting subtle signs of alien civilizations that we might otherwise miss. We must remain open to the astonishing possibilities that await us and embrace the unknown, striving to understand our true place in the cosmic tapestry.